Hey guys, how are you? Today guys, I show you my lapping style and the process, and then I will show you the how to read the indicator dial, like the flatness gauge, and then the importance of the surface finish. Okay, stay tuned. Hey guys, just a quick reminder, before you start the lapping machine, you need to check your lapping oil with abrasive, because those non-diamond powder will sink to the bottom, so you have to mix first before you start the lapping machine. Otherwise it will not work, you just have pure lapping oil without the abrasive. Okay, reset 5 minutes. So the time is easy, you just you want 3 minutes and then you reset. Okay, so if you want 2 minutes, go down, so minutes and then seconds here, and then you always go to reset so that the timer will follow. So 5, reset. Okay, and then lock it. Okay, then I'm gonna test. Okay, so by the way, this is 24-inch Kemet, so lapping machine. So before I start lap my parts, I need to check the table. I make sure the table is flat, like 0, by using a flatness gauge. Okay, so while waiting, I will explain to you what is this all about, this one here. Okay, now this is very easy to interpret. This left side here, they call light bands. Okay, those are bands. You can only see that bands when you using a monochromatic light. Okay, so no, monochromatic light. Okay, so I'm thinking about microns. So monochromatic light, so you can see the light bands if you use a monochromatic light. So monochromatic lights, that will determine how flat your parts after lapping. Now it says there that one light band, okay, one light band is equal to 0.000295 millimeters. That is the flatness. Okay, so let's say your lens or the port plate from your hydraulic pump or motor. Okay, let's say the flatness gives you 3 light bands. Okay, so 3, and then you measure the outside diameter of that lens. Let's say we'll give you 130. Okay, now since here is 127 and 152, so you go a little bit farther from 127, so around here, and then you match that three light bands, and then after the intersection you go down, and then you can see here the indicator reading. Okay, the indicator reading that is in your flatness gauge. Okay, so from here you can see 3 light bands and 130 diameter. That's the part. Okay, part across down, the indicator reading will be 0.0025 millimeters, so that is 2.5 microns if I'm not mistaken. So your table should be max 0.0025 millimeters flatness. Okay, so by using the flatness gauge. Okay, but for me I always put my table into 0. So if the table is more than 0, like positive reading, by using the flatness gauge, then you rectify you need to rectify by adjusting these rings. Okay, so if positive means convex, you have to move the ring in. Okay, move the ring in. So these are the conditioning rings. So if the table read positive over to from your specs, you need to move this ring in. Okay, so by adjusting here. All right, now if the table is concave, like negative reading, okay, so more than what you expect, so you have to move the these rings out. Okay, that's how you correct the lapping table if it is out. So for me, I always put this table 0 or negative 2 microns. Okay, for safe, because as the table run and we put parts here, and then in the long run it will get hot, and then it will deform the table into positive. So I rather go negative to 0 than positive. Okay, all right, so this time I'll show you how to check the table. So this is the flatness gauge. So you have the plate, which is your reference, which is the gauge for the make sure it's flat. So this is 0, this plate here. And then your dial here, you make sure you 0 that, you give a tap, you 0, and then that's ready. Okay, let's put that on the lapping table, and then we'll check 2 sides. Okay, this side first, give a tap. I'm reading 2 micron. Okay, each graduation is 0.002, which is 2 micron. And then I will do like this position and get the average. So that is 0. So I got 1 micron average negative. So by the way, if the arrow go to the left, negative, if go to the right, positive. So I have negative reading. So that's good. Table is flat. So by the way, guys, this is, they call this this is monochromatic light. Okay, and this one here is the optical flat. So what happened is, what you're gonna do here is you put your lapping part there, and then you place this on the top of your lapping parts. Okay, and then you switch this on, and then see that line on the top, that is your reference. And when you see that optical flat, the glass, you can see the bands. Okay, all right, so the bands look like this, looks like this. Okay, so if you see one round dark, means that is one light band. Okay, that if your part is, this is convex or concave. Okay, I'm gonna zoom it. All right, see, now the two light bands, you have two bands, okay, two dark, okay, and then so on. And then there's another pattern here. So this still, if you see this pattern, then when you see that line touching on the top one band and then on the bottom one band as well, so that's still considered one light band. Okay, same on this here, that is two light bands because there are two bands only touching by that line, that line there, this one. I will include in this video because I've done this before, then I'll just insert it how I did. Okay, so yeah, that's the reference if your lapping part is flat or not. So like for example, if I lap the lens, which is 3 light bands, so I should be able to see the 3 light bands. Okay, this is the monochromatic light. Okay, this is from Kemet. Okay, now when it comes to surface finish, guys, okay, most commonly used is the RA, which is the arithmetic average roughness. Okay, between that height there. Now in hydraulic, okay, hang on, so in hydraulic component, the roughness specification or boundaries, okay, you can call that, between 0.1 to 0.4 micron. Okay, this value here, you're in good okay, this value here will give you good balance and good oil film lubrication. If it is too smooth, okay, let's say less than half of a micron, okay. Now the problem of this surface finish, this one here or below, okay, it will affect your oil film lubrication. It may not adhere well, okay, during at start, because it will slip. Okay, the the film instead will stick, it will slip because too smooth. Okay, so that's why I go from here. All right, this is the roughness. Okay, surface roughness, RA, between 0.1 to 0.4. Below 0.05, okay, no good. Okay, because too smooth. Okay, so after I lap the workpiece or the parts, so this is a cradle, by the way. Now I'm gonna check my surface roughness. Okay, now I should be able to get between 0.1 to 0.4 so that I have a good balance and good lubrication, oil film lubrication. Okay, even under pressure. All right, okay, I'm gonna test and we'll see the result. Dang, dang, dang. Oh, 0.13. So it's good.